Okay. So, yeah, we have a lot of things that we have done in the last year, and I'm very happy that I can present these things to you now. Um, of course, such an update is consists of smaller topics, bigger topics that we have changed, and I won't go through all the details, but I will go to the the major topics. So yeah, you get a good idea of what we have done. Okie doke. Let me jump straight into that. Um, yeah, in Analyzer, we have the ability to put in trailers. That is nothing new per se. But we have changed the whole setup how trailers are done. Some of you have worked with Analyzer for years, others are completely new. Um, but what we have done is instead of three different options for trailers, where we have semi-trailers and like one axle trailers and tandem trailers, we now have the option that we set up the trailers in this dialog form, and we can choose it via a drop down here. And the special part about this is that this is a completely dynamic dialog. So if I change values here, you can see how the trailer looks is going to look in the end, because we got the feedback, and I totally agreed with that feedback, that our previous window to set up trailers was a bit clumsy, and it wasn't always super clear which value did what. And yeah, so with that, we can set up all the different trailer types. Also, if you're going for a semi-trailer or like a simple trailer here, yeah, that should be just much easier. I'm trying to go with all the changes with the new features from small to big to give you a big of an overview. So yeah, we have this dialogue new now. Another thing was that when you use layers and you put something in, let's say I have my drawing here, and I want to put something into a layer, I can do it, and then I go to the properties and say, okay, switchable, and yeah, let's say this is in layer 10. So we got the feedback by a lot of people that they tend to have all like they have their own order for layers. So now when you mouse over this, it just says layer 10, as it used to be. But what we can actually do now is we can go to the settings and give these layers a label. So I think I can say, okay, layer 10 are always, don't know, the witness statements, and then I can put all my changes, like all the information that comes from the witness statement here. And if I mouse over, I see that. That's useful for those of you who like to work in a very structured way of just and always do certain things in certain layers, and when then they go to court, they can like switch the layer on and off, and they never forget. Oh, okay, so layer 10. Oh yeah, this is my witness statement layer. I showed it, and layer 9 is maybe, don't know, from the other side. And yeah, you get the idea. So yeah, another little feature that we built in that was also a wish. Let's continue, since we are talking about graphics. Let's continue a little bit in that. So, since I think the pre-previous version in Analyzer, we have a maps tool where you can use Google Maps or OpenStreetMaps or Google Earth in Analyzer, and you can directly go in, search for your street where your accident happened, and uh, and if you found it, you can make a screenshot. There's nothing new. But the problem is, what if we have like a, a scenery that goes over a long stretch of road? If I make a screenshot now and then later zoom in, that looks super blurry. So what we can do is the following now. We can select a certain area, click on copy map, move it a bit further, click on copy map, and continue our way as long as we need it for the road. And once I close it, you can see that now all the copy maps that I've done are separate screenshots, and I now have the best resolution that Google Maps can offer here. They're all scaled properly. I don't have to do anything about it. They are scaled. I can directly continue with my report, and I don't have to bother about like a lack of details when I zoom in, because I still have at least the best resolution Google can offer. So yeah, that's another little feature. By the way, if you have any questions, please write them in the chat. And in the end, of course, we will also have the option to talk verbally about your questions. Okie doke. I'm going to delete them again and continue with the next feature. So let me open 3D for that maybe. So one tool that we are having for quite some time now is this little tree tool. And the tree tool is basically here for placing static objects in my landscape. And I know these days we have laser scanners, we have 3D photogrammetry. So sometimes like most of the times, we might have already a great 3D landscape and a 2D landscape. But sometimes, well, we just want to do it ourselves and just quickly, but still give it a nice appearance. So what we have done is we have expanded the database of 3D objects, static 3D objects, quite a bit. You see, we have here houses, then we have trees, we have big street objects and smaller street objects. And whenever I click here now, I get the house in the exact spot where I click. I get a simplified 2D sketch. When I place another one, I get it next to it. And we have all types of houses. Maybe let's pick a more modern one for the other side. You can see modern house over here. We even have medieval houses in case you are in some European old town where you want to put it. We have all types of trees, so that we can put in. You can see, and whenever I click somewhere, we get our nicely designed three-dimensional trees in the same spot as the 3D model, as the 2D model. I can even put in a billboard. There we go. This is definitely not biased. And of course, we also have smaller or bigger elements that I can just put in here. And with this, we are able to create lovely landscapes if for some reason we don't want to use a laser scan or a 3D photogrammetry, and it really makes like a difference visually to have just a proper environment for our accident scenery. Another thing, some of you that work a little bit longer with Analyzer is that you might have recognized it, but suddenly our trees also have shadows. So the thing is, we have completely renewed our light and shadow engine. So everything has proper shadows now, and yeah, and light sources are acknowledged in a better way than they used to be before. We didn't do that so much because we think shadows of trees are so damn important, but rather for a different reason, and that's the following. Let me just put in a car. Don't know what kind of car do we want. Let's pick a Ford. Yeah, plenty of them. Okay, let's just pick this one, Ford Edge. And I'm going to let this Ford go around a little bit with 10 kilometers an hour. So far, so good, right? And I'm going to make it a little bit darker now, so you actually see what I plan to show you. So one feature we have implemented due to the idea of someone is that we are able now to put in a light source into a vehicle and use this as a way to show visual effects. So as you can see here now, we have suddenly this little white sphere which should be placed where the head of the driver is. And then we can see what the driver can see in his position, and what is blocked here visualized through the shadow by, let's say, the A-pillar. And if you now, for example, press play, you see how the visual situations change according to the site limitations. And I think it's a good way of showing these things. Of course, previously we had things like or we still have, of course, our line of sight, which shows it in 2 dimensions, but this gives it makes it way more visual, yeah, with a certain overview than it used to be before. Another thing that we built in, but beware, this is only for animational purposes, it's not an accurate physics simulation, is we put in the front lights of the car, so you are able to put those in. But again, this is only symbolic, I would say, and not the accurate type that this type of car has as a front light. Okie doke. Then, next topic is something regarding CDR. For those of you who have already worked with Analyzer, you know that we have quite a powerful CDR tool for reading in CDR data. But we have expanded this tool again. Oh, sorry, I've switched it to German. Give me a second. Switching it back to English. Okie doke. So CDR data. So in our CDR data tool, for those of you who haven't seen it yet, I'm going to present it quite briefly. You load your CDR file. It shows you which data is available, like which pre-crash data does it read in, which crash data, and you can see the speed profile here. You have the option to see it also in a numeric table view if you want. You can show diagrams of the data you have if it's interesting. You can visualize the driver's behavior and see, okay, just to get an idea what the driver did, how he changed the steering wheel. Was he braking? Yeah, here. Was he using the accelerator? No. What's the speed? What's uh, the engine rotation? And so on. You can export it as a CSV file. Okay, that's not so interesting. You can manually change the data unless you, like if you want to put, if you want to put like data that you only have as a PDF file, you can create it here and then write it manually in, or you can copy data from a read-in file and and change it if there's some error in the file, of course. And yeah, and what you can also do is you can, of course, put all this data directly to Analyzer, and you can use it by transferring the steering wheel angle. So when I'm doing this, I'm selecting the whole range. I am going around the curve. And like you can see, okay, when acknowledging the steering angle of the car and the steering ratio and the speed, we get this driving line out of the car. What is new in the new version is that we can give tolerances for the speed because the speed values are not always super accurate. So maybe sometimes you want to work in a way that you say, okay, now I want one version with, don't know, 5% less maybe, and then another version with 5% more. And yeah, that's another thing, and we can put it in as two versions. But the biggest news probably in this area is about pre-collision skidding. So the data we're having here is, or the pre-crash data we're having here is all fine and great as long as we don't have pre-collision skidding. Because if we do, the steering angle and the speeds that are measured are no longer accurate for our car. And what we have done is we created a tool that allows us to make a correction calculation in case that happens. The condition for that is that we need longitudinal acceleration, lateral acceleration, yaw rate, and steering angle in the data. And then we can actually calculate the trajectory of the center of gravity that is corrected with this accelerational values. And let me just show you, for instance, what a difference this makes. I'm clicking on transfer. And now you see I have my version number 1, where I just straightforward read in data and say, okay, the steering angle is correct and the car is following as it wants to steer. And then we have a second version where we do our correction and where we actually see, oh wow, the car is not going around the curve. I mean, this is becoming very visual if you, let's say, have the situation on a highway and the highway doesn't make a curve, but the car does with the data. But then something like this makes way more sense. And yeah, and then we see, okay, we have the car here drifting sidewise, trying to steer, but it doesn't work anymore. And we arrive in the collision position with the correct yaw angle uh, and uh, and also with the correct speed. So makes all the difference. And again, it's so important to note that we have like when we have data, it's great, but but we should not blindly just read it in and assume that everything is there is yeah, is just a given. Yeah, so that should help you a little bit in that direction. Let's continue to the next topic. Again, if you have any questions, please write them in the chat and let me know. Closing that one now and opening another one that I've prepared. And that is about pedestrian slash bicycle accidents. So you know that in Analyzer for quite a while we have the barrier method or limit method, probably is a better word, to calculate traffic accidents that involve pedestrians or cyclists. The condition for that is that we have the final position of car and person. The bicycle is not so important, and it's a way of calculating collision speeds and collision locations. I'm going to quickly go through the module. So I've prepared here the vehicle data already. I set up, oopsie, where is it now? Oh, there we go. I set up the final position. I give it a range of a potential collision location. I say, okay, yeah, maybe it's somewhere within here. I put the final position of the person. And I put the final position of the bicycle. There we go. And then I can walk through my limitations. So maybe I say, okay, there's a deceleration of 7 plus minus 1. I'm selecting my theory that is depending on what kind of case I have. Again, this is in the technical manual, which theory is used for what. And I get a result. Okay, I see now, okay, this is roughly 70 to 85 kilometers per hour. And I can do now a calculation to double check with throwing distance. All of that is nothing new. I can just quickly show it to you how it looks like. Okay, with the throwing distance, I get on medium range 75 kilometers an hour. And what we have added now, as it was suggested by one of our users, is that we also added in the theory published by Seal about throwing distances. So there is, I think in the 80s is the first paper published about that topic, and it has been revisited a few times. So this gentleman has built up a set of formulas with which you can calculate throwing distances. Yeah, so this is a way of double checking it using the theory of Seal. We can export the data and then continue with our pre-collision and have yeah, our movement of the car. So yeah, nice little expansion on that topic. next topic, actually. So the next topic is about uh, contract traces on a vehicle, like that are done by vehicles on other rigid objects. And I'm going to load that for you and maybe make it a little bit bigger. So I don't know if you're familiar with the theory, but what you can do is if you have traces like this on a car that are, or on a static object, uh, that are done by by a rotating wheel that is scratching on the side, um, that leaves these marks. And it is possible to calculate relative speeds between the two cars. So if one is static, of course, the absolute speed, but maybe if both are moving, just the relative speed. And this is done by this module. So I'm scaling the picture in a first step. And then I can adjust my traces. Let me just change the color maybe so you can see it a little bit better. And I can change my values to see, okay, how do my traces change if one car has a certain value? Oh, how do my traces change if another car has a certain value? And as you can see, I'm doing that till this the shown traces match the calculated traces, and with that I can calculate my difference in velocity, which can be useful tool. Again, this is like a fully dynamic dialog. I can, for example, reduce the maximum height, and you see it here. You see it here in the graph, and it hopefully should be easy to use. Furthermore, it is possible to calculate the traces that are done on the rotating wheel itself. So also that is a possibility. And again, by comparing, you can calculate relative speeds. Okay. Next topic. So some of you are probably aware of the NATA database. It's a database published by the US government, and it contains thousands of crash tests that are freely available to for everyone to use because it's tax funded. And the NATA database is of course focused a little bit on US vehicles, but still quite useful. The only problem is many people don't know about it, and it's a bit clumsy to use maybe when you work like go through it on the homepage. And this is why we put in direct integration into Analyzer. We can search for a vehicle. We can select the crash test that we want, and then it loads the vehicle, and we see preview pictures here of the car. We have information on like what data was used here. We see there are a lot of videos. Sometimes there is CDR data, for example, and UDS data, and so on. And if you then want to have this crash test, you just basically click download. I'm not going to do it now because they usually have a few gigabyte, but yeah, you get the idea. And with this tool, you have super easily the access to the full NATA database. You see it has 12,993 elements. Yeah, so quite a lot of data that you can use too. Again, this was a suggestion of a user, so thank you so much. If you have ideas, please always yeah, bring them in. We highly appreciate that. Okay, so all of these news were, yeah, some of them bigger, some of them smaller, some of them more effort, and some of them less effort. But the probably biggest project, by far biggest project we have ever done in Analyzer is that we have completely implemented a new vehicle dynamic system. We have done this in cooperation with a project that is funded by the US military and developed by American university and an Italian university. And this allows us to now simulate vehicles in a way that is preciser than ever before and also allows us to do certain things that we're not able before, like rollover of vehicles, for example. The tool or the is not fully finished yet, and it will take some time, so it will gradually be released within version 25. We were thinking about if we just should the whole thing release only in version 26, but then we thought like no, there is already a lot of like meat to it that you can work with, and yeah, and in order to show you what's happening, we have prepared a little video, and Florian, my co-founder, will describe a little bit what's going on in the in there and what we can do with the new driving dynamics. Okay, and Florian, the
Thank you.
stage is yours.
Thank you very much. So hi, good evening, everybody from my side as well. What you're currently seeing here is me using the new driving dynamics feature that we have created. The way you use it is, as you can see, you open it just over the kinematics view, so you don't need a second view like in the old collision analysis. This dialog then pops out and you can set, as I'm doing in the video, initial data of the vehicles involved. You place the vehicles in the initial position, which is for the new dynamics system no longer the collision position. And then you set initial speeds, initial material parameters, which are important for the collision itself. And then you press on calculate. The program in the background will simulate and will give you out all the simulated frames as they become ready. The way this is mainly different from the old driving dynamics and collision analysis is that this uses the force balance method for calculating the collisions. Previously, we used to have the momentum calculation. So you would say a collision occurs in only one spot at one time. However, now we have, as you can see here, three-dimensionally a couple of overlap points between every three-dimensional mesh that collides. And we calculate forces and reaction forces at the same time for this vehicle, for each of the vehicles that are crashing into each other. So during intrusion from the first contact onwards, we have a combination of both driving dynamics, meaning tire forces are being calculated, as well as the forces acting on the chassis. These points where you can see the vectors, they can be deformed live as well. So in real time, these arrows will push the mesh and will create three-dimensional deformations. Mathematically, this is already implemented, but you won't yet quite be able to see it. We're working on implementing that. Um, the tires during all of that are in contact with the surface. The surface is now also a object with which we can collide, which the tires constantly do when they roll, and also the chassis can collide with the floor now when we have a rollover. The vehicles are slightly multi-body constructs already. So they consist of a chassis of 4 wheels, of a drive shaft, a transmission box, as well as the engine. The engine will create a torque, which will then be transformed to the tires. The tire model that simulates the forces is the easy tire model. If you're familiar with that, that models the forces of the tires and the floor. And yeah, we also have a general physics simulation, so we can add additional objects to the whole thing. If you're done with what is simulated in here, as always is the case with Analyzer, we can export it into the kinematics, and then we can combine it with all of the rest of the pre-collision, as is usually the case. The new phase that all of this gets exported into is called simulation. So we don't have an overflow of a bunch of phases that will all be a millisecond in length, because every simulation integration step is a millisecond. I also have this second example here, which has a bit of a more nice looking landscape. This right-hand curve from the direction of the blue vehicle, which we see here, is it's a bit of a dangerous curve. The blue vehicle drives on it a bit too quickly, loses control, and starts skidding into the red vehicle. One of the features the new driving dynamics simulation allows us to do is a so-called pre-simulation step, where we adjust the whole chassis and all of the suspension to a stable state of whatever driving dynamics behavior the user requires us to have. So we here have entered a certain steering angle for the blue vehicle. We've entered a side slip angle and a yaw rate to the clockwise direction. And we can simulate that now. So the user doesn't really have to think about all of the suspension setups. We get the correct one pre-simulated. What I'm doing now is, after simulation, also exporting it to the kinematics and then adding the pre-collision of a couple of meters of extra driving. So we don't just get the dynamics, but we also get the pre-collision, which is the way we usually handle collision and pre-collision. So kinematic pre-collision, simulated collision. Nothing here really changes. We can also look at the 3D, just to also show off the new 3D options a bit. So we have the new houses and the new trees with the new shadows here as well. And yeah, pay attention to all of the springs of the suspension of the blue vehicle. We have all of the three-dimensional angles, as well as a three-dimensional collision itself. You can also, of course, look at it from the point of view of the car. Now we are in the combination of the pre-collision with the collision. What we've seen so far of this feature is the base functionality. As Matthias already mentioned, this thing is not done yet. What we see here are basically the building blocks to have more and more features in the future, some of which will be released in version 25, some of which will be released in version 26 then. Those include not only the rollover, but also three-dimensional visible deformations, driving on 3D landscapes like Agisoft, as well as um, in later versions then including solid obstacles, trailers with which we can do collision analysis then. And as a final step, we would like to have a multi-body system with which we can handle pedestrian accidents better. Are there any questions so far about this
Well,
topic?
Florian, thank you so much for your presentation. And with that, we come to the end of what we have um, prepared for this version. Um, and I hope you like it. I hope there are some things for you there that are useful. Uh, if you have any questions, please let us know. Write us. I'm going to quickly share my screen for a last time. There we go. Um, for those of you who are already a little bit experienced with Analyzer, we have next week a 4-part advanced course coming up. Um, and uh, if you are new with Analyzer, just reach out to us. We have video materials to get you started right away. Version 25 is not fully out there, but it can be pre-ordered now. It will be officially released in December 1st, 2024. That's so far everything from our side. If you have any questions, then this is the time. And otherwise, I wish you a lovely rest of the day. Thank you.
Thank you very much. Have a nice evening.